Hello everyone. We are not going to do a warm-up today since I am not here. So instead, what I need you to do is get your notebooks out and flip to the front part where you have your notes. Okay, so these are the learning targets. You don't need to write these down. Remember, we already had a couple of learning targets that we've talked about. We've talked about characteristics of living things. That's the first one. And the second one is figuring out the age of fossils and rocks by using half-life, okay? So the next two, which are kind of the big ones of this unit, are I can list the four main biomolecules, identify the function of each, give examples of where those molecules occur, and list the elements found in each group. Okay, so this sounds like a lot, all right? We're going to break it down though. Basically, carbohydrates, proteins, lipids, and DNA, you need to know the function, you need to know examples, and you need to know elements, okay? So those are the things you need to know for the test, which will be next week, okay? And then you also need to be able to identify similarities and differences. Apparently, I cannot draw today. Guys, so the first thing that I need you to write down is the definition right here of biomolecule or macromolecule. So go ahead and write this definition down. A biomolecule or a macromolecule is a large molecule. A lot of you guys told me that macro means big. We know micro, M-I-C-R-O, means small. So macro means big, okay? So a macromolecule. Now you can use either of these words, biomolecule or macromolecule. They mean the same thing. Okay, a large molecule, we know they're large molecules, and they're made by living organisms. Okay, that's why we have bio. Remember, bio means life. So large molecule made by a living organism. And remember, we said the most important element, remember elements are one letter, right? Like a C or an H or an O. Those are all an element because we find them on the periodic table and they're one capital letter, okay? The most important element for living organisms is carbon, okay? So that's what we're going to be talking about. So we talked about the difference between an element, right? One letter, these are all elements, or a compound like water, H2O. It's got two capital letters, right? Two elements, hydrogen and oxygen. So the four main biomolecules or macromolecules, again, we're going to use both of these words. They mean the same thing, okay? Are proteins, carbohydrates, lipids, and nucleic acids, okay? So go ahead and write that down. Four main biomolecules are proteins, carbohydrates, lipids, and nucleic acids. While you're writing, you can look, there are some pictures here of examples of carbs, proteins, lipids, nucleic acids, okay? You'll also notice that there's some other elements that we use as well, like oxygen, hydrogen, nitrogen, sulfur, phosphorus. So we use other elements to make up some of these big molecules, okay? So again, a molecule is just a whole bunch of those letters stuck together. It's a compound, okay? Proteins, carbs, lipids, and nucleic acids. Now, you guys are going to have a quiz on this on Friday, okay? So on Friday, again, quizzes are on the computer. They're 10 questions long. They're all multiple choice, okay? And it's just going to be on these macromolecules, okay? So we'll do lots of practice, don't worry. All right, next thing, you don't necessarily need to write down this top part, okay? But macromolecules, they're large molecules, we know that, and they're made up of smaller repeating molecules. Again, you don't need to write that down. Let me give you an example, okay? How many of you have built something out of Legos? Okay, let's say you want to build a Lego castle, all right? So you and your brother make a Lego castle. Well, that Lego castle is built out of smaller building blocks. What are those smaller building blocks? Well, the Legos, right? So we call the building blocks, the smaller things that these big molecules are made up of, we call those monomers. So what I need you to do is I need you to write this definition down, monomer. Anyone know what the beginning of the word mono means? Mono means one. You may have heard of like the sickness, mono. That's short for mononucleosis, meaning it's got one nucleus. So a monomer is a building block molecule. It's like those Legos, okay? One Lego by itself is not going to build a Lego house or a Lego castle, but if we put a lot of them together, they're going to build that Lego house or that Lego castle. So what happens is we put together lots of small molecules in order to make these big molecules, okay? So these monomers, these building blocks, these Legos, we put together and we make big molecules. And the big molecules are called polymers. Poly means many, okay? So write that down. Polymer, a large molecule made by connecting monomers together. And this is what macromolecules are. They're polymers, they're big molecules made by connecting these smaller molecules together. We can also use an example of like beads, okay? Beads are the monomers. They're the building blocks. If we put them all together on a string, we make a necklace. A necklace is going to be the polymer, okay? So basically all I'm trying to say is these big molecules like carbohydrates, lipids, proteins, nucleic acids, they're made up of smaller things that we can identify, okay? And I'm going to have you practice identify those in a second. So what I need you to do is find that bag of cards on your desk. We're going to be doing a lot of work with these cards, okay, different types of cards, and spread them out. So take that Ziploc bag of all those cards, spread them out on your desk. And when you have that done, you should have something like this, okay? Now, does anyone remember what a carbohydrate looks like? Anyone remember from our investigation what a carbohydrate looks like? Carbohydrate is a hexagon. See if you can pick out one of the hexagon molecules. I'll show you up here. Here is a carbohydrate, okay? This is a monomer because it's just one molecule, okay? What I want you to do is can you connect some other monomers of carbohydrates? So find some other carbohydrate molecules. Can you connect them to make one big carbohydrate molecule? So find the other carbohydrates. What are the other ones that look just like this picture, the one that I circled? Can you connect them to make a polymer? If you're stuck, look up here. Here's what I should see, okay? I should see you connecting all three of these carbohydrates together on your desk because together those make up a chain of these building blocks for carbohydrates. Okay, good. Next step, here's what I need you to do. I need you to find a lipid. Lipids are fats and they look like long chains. Can you find the one that looks like a long chain? Find one that looks like a long chain. You've got a couple. So show me a monomer of a lipid, right? A one molecule of a lipid. Right? So here's one, right? Now, can you connect some other lipids together to make a polymer of a lipid? See if you can find the other lipids. Find the other ones that look exactly like that. Connect them together so that you can make a polymer. Okay, so here's what you should have on your desk. Right? You connected them together. Now, we don't know exactly how these connect, and I'll tell you, here's how they actually connect in real life. They connect like this, but it doesn't matter. All I want you to know is that they're connected together to make a big molecule, a polymer. All right, Next up, find a protein. A protein has the letter N in it. It has C's, H's, O's, and N's. Can you find the building block of a protein? Here are the letters it has. It doesn't have any P's, just C's, H, O's, and N's. All right, so you should have found this molecule right here. Okay, this guy. Now what I need you to do, that's a monomer, right? It's one. I need you to make me a polymer. So find its other monomer friends, its other building blocks, okay? And line them up to make a polymer of a protein. So here's what you should have. You should have them all lined up in a row just like this, okay? All right, the last one I need you to find the one that has a letter P in it. This is a nucleic acid like DNA and RNA. Find the one that has the letter P. Okay, here it is right here. Is this a monomer or a polymer? Is it one or is it many connected together? Have we connected many together yet? We haven't, so it's just one, so it's a monomer. Okay, so find its other monomer friends. Find the other ones that look exactly like this. Connect them together to make a polymer. So here's what I should see on your desk. Okay, so see, they're all connected together. All right, that would be a polymer. Okay, so here's the test. All right, this molecule that I'm creating up front, is that a monomer or a polymer? Is it one, mono, or is it poly, many? This would be a polymer, right? Good. So all I need you to know, I don't need you to memorize the difference between the carbohydrates, proteins, nucleic acids, lipids. I don't need you to memorize the difference between those right now. All I need you to know is that if there's one thing, it's a monomer. If there's a lot of them connected together, it's a polymer, right? So this guy by itself is a monomer. But if I connect it with his other friends, it's a polymer, okay? So there's our difference between monomer and polymer. Okay, and again, the big molecules we're learning about, carbohydrates, proteins, lipids, nucleic acids, they're all made by connecting these little building blocks, just like Legos, all together. Here's the last slide we're going to be writing down today. Okay, we said that macromolecules include carbohydrates, proteins, lipids, nucleic acids. By the way, you can put all of the cards back in your bag. We're done using the cards, but we will use them when I get back on Wednesday, okay? Put all the cards back in your bag. So we've got carbohydrates, and that's what we're going to learn about today. Just carbohydrates, not proteins, not lipids, not anything else, okay? So carbohydrates, these are the main energy source for organisms. They give us short-term energy, so they give us energy really quickly. You need to write this down, okay? You need to write everything on this slide down. You do not need to draw the pictures. So main energy source for organisms provides short-term energy. Think about this. Skittles, you guys found out, are examples of carbohydrates. They have a lot of carbohydrates. What happens if you feed your 2-year-old brother a lot of Skittles? Well, he's going to go run around the room like crazy, right? Because he gets lots of energy right away. You might have also heard of like a sugar crash. Okay, when they end up like getting really tired later. Well, that's because carbohydrates only give them energy for a little bit. It's short-term energy. It's not energy for a long period of time. It's just energy for a short little bit. This is what organisms use as their main source of energy. Okay, now again, I have people ask me, are carbohydrates bad? They're not bad. Unfortunately, one of the trends right now are low carb or no carb diets, okay? People think that by going on these diets, they can be healthier. And sometimes they can, okay? But the goal here is to eat lots of different types of foods and to eat lots of whole foods, okay? That means vegetables and fruits. So a lot of times what happens is if people aren't eating these carbohydrate type things, they're eating more fruits and fruits and vegetables are good for you, okay? It's not that carbohydrates are bad for you. It's just that we want to eat lots of different foods, okay? Like for example, if I ate just bacon, it wouldn't be good for me. Or if I ate just bread all day, it wouldn't be good for me. Or if I just ate apples all day, it wouldn't be good for me, okay? We need a variety, all right? And a lot of times, people in America don't eat a lot of fruits and vegetables. They don't get a lot of variety, okay? All right, so what letters do carbohydrates contain? They contain C, carbon, H, hydrogen, and O, oxygen. Okay, so C, H, and O. Again, you're writing all of this down. As you saw in the activity from Thursday and Friday, they are a hexagon shape, okay? So they often have this hexagon shape. And a lot of you identified that. You put some of these molecules, you grouped them by the fact that they have hexagons. Now the monomer, remember we said, what's the building block? Okay, for example, right here, can anyone tell me how many building blocks is this made of? How many hexagons do we have? Remember the building blocks are called monomers. So what is the name of this specific monomer? That's what I'm going to tell you. But this has, look at 1, 2, 3. So it's made up of 3 monomers, right? So this itself is a polymer. It's a big molecule. It's made of smaller units, okay? So we have special names for the building blocks. For example, if you were to make a castle out of Legos, it'd be different than a castle you made out of Connects or a castle you made out of building blocks, okay? So different molecules have different building blocks, all right? So for carbohydrates, theirs looks like a hexagon, and this hexagon is called glucose. Glucose is a sugar. Okay, so the hexagon here, the building block, is called glucose. Now, lipids and proteins, those are going to have different building blocks because they look different and they're made out of different things. If they were all made out of the same thing, we wouldn't have different names for them. All right, last thing here. Examples include sugars, any type of sugar. It ends in ose. Can anyone think of anything that ends in ose? Maybe you've heard of sucrose. Sucrose is the sugar you use for baking. It's the sugar you have in your kitchen, right? You put in cookies or, you know, maybe your parents put it in their coffee. Okay, so sucrose. Maybe you've heard of fructose. That's the sugar in fruit. Maybe you heard of lactose intolerance. Lactose is the sugar in milk. So anything that ends in OSE is going to be a sugar, and it's going to be a carbohydrate. Starches, we're going to talk about those, but like bread and potatoes have starches in them. Fibers, so like the Fiber One bars that you're eating, that has fiber in it. Fiber is a carbohydrate. Fruits and vegetables also have fiber in them as well. Bread, pasta, okay? All of these are examples of carbohydrates. So once you have this written down, you are good, okay, with your notes. Here's what I need you to do. Many of you were here on Friday, okay? Many of you were not. On Friday, we got a worksheet. This worksheet looks like this. It says elements and macromolecules in organisms. If you have this worksheet, what I need you to do is take it out. If you don't have this worksheet, don't worry, okay? So people who have the worksheet, you're working on the back side or whatever you don't have done, okay? And I expect you to turn it in to me today by the end of class or tomorrow, okay? If you didn't get the worksheet yet, you're gonna raise your hand and the sub is gonna come give you the worksheet, okay? We worked on this on Friday. I also emailed it to you. So Again, if you're ever gone, check your email or have your parents check their email. Sometimes I will email you, okay? So if you were gone, what you're gonna do is read all the info at the top, and then you'll need some colors. Okay, you'll notice that for each of these letters, like C says black. So what you're gonna do is you're gonna color the C black, that stands for carbon. And then you're gonna color the part of the squirrel that has the C next to it. Hopefully you're a better colorer than I am. Black as well. And this represents in the squirrel, the percentage of this squirrel that's made out of carbon, out of C. So we're gonna look at the different elements that make up this squirrel, okay? So then same thing, hydrogen will be yellow. So you'll color that yellow, okay? And you will color the part of the squirrel yellow as well, all right? Now, I expect that you are working in your seats, okay? In your assigned seats, and that you're not running around and you are not on your cell phones, okay? When you are done, you need to turn this in to my basket. I would like both sides done by tomorrow, okay?